So today I'm talking to my friend Carl. Carl and I didn't ever work at the same company, but we worked together. He used to be at a database company called Single Store, and I wrote the Single Store driver for Laravel, and so we got to work together a bunch. But these days, Carl's doing something extremely interesting, and so I wanted to talk to him. So, Carl, welcome to this not show about SQLite, and tell us what you're up to and where you're at now.
Thanks, Aaron. Super excited to be here. Yeah, so I mean, as Aaron said, I worked at Single Store for 10 years. Single Store used to be called MemSQL, so it was a little database company. We started with this dream of making, high performance combo of like analytics and transactions in the same system. And I think we did a pretty good job. Single Store, after 10 years at Single Store, I decided that I really wanted to try some new things, still in the data
Mm-hmm.
space, but just doing my own thing. And so I decided to leave Single Store and start something new. Currently, I am technically an entrepreneur in residence at Amplify Partners. Amplify
Oh,
Partners
cool.
is a venture capitalist in San Francisco. And I decided to take on this role because it allows me to pursue my own ideas for some amount of time. So it's sort of starting my own company without committing 100% into going right into like finding product market fit and finding like
Hmm.
that sort of company drive. So it's sort of a wiggle room space. Um,
Yeah.
with Amplify, I have sort of started a company, I guess. It's called Orbiting Hail. It's just me right now, so it's more just like me and a bunch of ideas
Mm-hmm.
around data and databases and web technologies. And most recently, I released a project, my first project called SQLSync,
Mm-hmm.
which is probably what we're going to be spending most of the time talking
Yeah.
about. SQLSync is basically a wrapper around SQLite, so it's completely vanilla SQLite. Nothing changed there. And the wrapper basically implements multiplayer SQLite. So you can have
Hmm.
SQLite running in a bunch of different web apps, or the same web app, but in a bunch of different tabs or windows or whatever. And they can all communicate with each other through SQLite as sort of a central database point of communication. So that's what I've been
Super
up
cool.
to,
So
and
let's.
yeah.
I do want to talk. Yeah, I mean, I do want to talk about SQL Sync a lot, but I this entrepreneur in residence thing that's super interesting. So you were like my perspective on you at Single Store was you were like the mad scientist. Like you knew everything. I didn't ever really know what your job was, but you were like, oh, if there's a problem, you just talk to Carl. Carl will fix it. And so you came out of that. And how did you get hooked up with this VC firm? And are you the only entrepreneur in residence over there?
Great questions. Yeah, so I started chatting with Amplify about 2-ish years before I left Single Store.
Mm-hmm.
Not with the intention of starting anything or leaving Single Store. It's
Mm-hmm.
just that while I was at Single Store, as you said, I was a bit of a mad scientist.
Mm-hmm.
My last
I'm
project,
glad you agree with that. I'm glad you felt the same way.
yeah, everyone at startups fulfills different roles. I was definitely in the
Mm-hmm.
like generalist space where it was sort of, if you don't know who to do something, you can always send it to Carl and he'll figure it
Mm-hmm.
out. That was sort of a role I really enjoy, especially at a small, super agile company like Single Store. Um, so yeah, the last project I had to work on at Single Store was adding WebAssembly to Single Store. So the idea
Hmm.
that my team had was, what if we took WebAssembly and we allowed people to write WebAssembly programs and embed them directly in the database as user-defined functions, table-valued functions, user-defined
Cool.
aggregate. So basically, add extensibility to the database via WebAssembly.
Mm-hmm.
And so my team was working on that, which was super, super fun. And through that, I met Amplify because Amplify was really excited about WebAssembly. So I met Renee and Sunil through that sort of connection within the like WebAssembly space and everything. Stayed in touch with them, and then when I eventually got to the point where I was like, oh, maybe I want to do something new, I talked to pretty much everyone in my network, including
Mm-hmm.
Amplify. And Amplify sort of proposed this idea of doing an entrepreneur residence. It's not something that every VC does or they do with everyone. But for people like me, where I knew I wanted to do something, but I wasn't entirely sure what it was, I needed that
Mm-hmm.
space and that time to sort of figure it out. That's exactly what the entrepreneur residence program is sort of designed to provide.
That is super interesting. It sounds awesome. 10 years, by the way, is forever. So I can understand that you like were looking for a new challenge after 10 years. I don't know if I've done anything for 10 years. Coming up soon in December, I'll have been married for 10 years. So that counts. But like, I don't know what my longest job is, maybe 4 or 5 years. So now you're out there. You're the entrepreneur in residence. You're out there. You have created this thing called SQLSync, and you say it's vanilla SQLite, which I am intrigued, but there's some sort of wrapper around it, and it works in the browser. And I played with your demo for a little bit, and so like, give me the high level of like what the I guess what the use case is, and then the high level of how it's implemented, and then we can dive into some technical details.
Yeah. Yeah, so we'll start with sort of like the use case, like why would you want something like SQL Sync? Um,
Mm-hmm.
my dream of SQL Sync was to just make it really easy to make multiplayer web apps that specifically needed like a relational data model, right? So like there
Okay.
are many ways to implement multiplayer web apps. There's a lot of companies right now playing around with these ideas. Like Electric SQL, for example, which I'm pretty sure you know pretty well because I think
Mm-hmm.
you're working with Electric SQL right now, right?
I'm
Or
working with Terso with
with
libsql.
Terso. Sorry.
Yeah,
There's
yeah,
too
yeah.
many. There's too many SQL
There's
companies.
a lot. Yeah.
Sorry, you're working with Terso, but there's also Electric SQL, which is doing really similar things
Mm-hmm.
to do like collaborative sort of. Actually, they're using sort of more like Postgres. Although they also use SQLite under the hood. Uh, so there's a bunch of companies doing this. The idea was, can I make this just like super super easy? That was like idea one. Idea two was, can I eliminate the can I make the way in which multiplayer actually is implemented simpler to reason about? So that was sort of option two, and we can talk more about how I did that and like how I think I did that. I hope it's easier to reason about at least. And then so that was the two things, and then option three was like, can I keep this as vanilla SQLite as possible? Like, can we make this
Mm-hmm.
like very very much just like it's just regular SQLite, and then we're just doing something creative and sort of magical to make it multiplayer.
Okay.
So sort of trying to combine those goals into something called SQL Sync.
Okay. So this is great. I love this so much because when you're the host of the show, you get to ask all the questions, and I have so many questions because I understand very little of what this is, and so this is like my learning opportunity right here, and it delights me. So let me ask you this: you you talked a lot about like real time and collaboration. I'm not super familiar with something like PartyKit. Is this in the same space of something like that, or do you know what that is? Because I've seen a lot of people talking about like add real time with PartyKit, but as far as I understand, your distinction is relational database real time. Is that close?
That's actually like a really, really good question, like a really insightful question, because we can sort of break up how you implement multiplayer for an app
Mm-hmm.
into a couple different domains or like
Okay.
different areas. PartyKit satisfies the transport part of multiplayer. Basically, you can think of PartyKit as providing like a session backend that a bunch of
Okay.
different clients can all connect to and can exchange messages. And
Okay.
then once you have a PartyKit backend, you can host a data structure in that backend that all of these
Okay.
different clients can sort of communicate and exchange information about. And
Okay.
so PartyKit you can think of as essentially a sort of like a stateful serverless process that a bunch of different clients can all connect to without having to pre-configure the existence of that server. So like if in traditional server architectures, I would spin up like my VPS or like my Amazon EC2 instance or
Uh-huh.
whatever, some instance that would be my server, and then all my
Mm-hmm.
clients would connect to it, right? So I'd have one
Mm-hmm.
big server for all my clients. PartyKit sort of takes it one step further to say, well, actually, what if we have sort of like one server, but we make those servers dynamic so they come up whenever they're needed and they go away when they're not needed. And we
Okay.
associate each server with like a concept of like a session. So if you wanted
Okay.
to use PartyKit to implement like a chat, for example, you would
Got it.
implement a party, which is essentially a durable session server. You
Silly,
would
but yeah,
implement
okay.
a party for each of your different like chat rooms, right? And so
Okay.
everyone who's connected to the same chat room would be connected to the same durable sort of like dynamic serverless server.
And in that model, I know you don't write PartyKit, but you seem to know everything about it. In that model, who owns the durable part? Is PartyKit a SaaS, or who like the
Good question.
serverless thing? Someone has to orchestrate it. Who is that?
I will caveat, I may not know everything about PartyKit. I probably making some mistakes. So if anyone on the
That's great.
internet catches me on something,
Yeah,
please let me know. I don't work.
they will. Don't worry. They'll
Yeah.
let you know.
But as far as I know, PartyKit was based on or is based on Cloudflare durable objects.
Got it.
I'm
Okay.
not sure if they have like other kinds of
Cool.
backends. But you can think of this durable object abstraction as like the infrastructure that is necessary for something like
Hmm.
PartyKit to exist, right?
Okay.
And the reason why I sort of know a bunch about it is because sorry, I almost said single store.
Yeah.
It's been a couple of years and I still say it.
Yeah.
SQLSync uses durable objects as its infrastructure provider, right? For the
Got
exact
it.
same reason that PartyKit does. So
Okay, and we're saying when we say durable objects, we're saying capital D, capital O. So
yeah,
Cloudflare durable objects.
yeah, exactly. So the
Okay,
durable
cool.
object service at Cloudflare.
Got it. Okay.
And SQL Sync needs that same sort of functionality because basically the way that SQL Sync works from a networking perspective is that we have a bunch of clients. So we have a bunch of different, like let's say you and I are working on an app
Okay.
together using SQL Sync as our multiplayer system, right?
Okay.
So the To-Do app, which I guess we can like link somehow in when you post
Yeah, I'll put it in some
the
notes
To-Do app is a good
somewhere. Yeah.
example. So let's say we're both using this To-Do app. So it's a shared to-do list. What's happening that what SQL Sync does is it uses Cloudflare durable objects to allocate a durable object that is for the database that backs that to-do list that we're both working on.
Okay.
And so our two web browser tabs, for example, are
Mm-hmm.
not communicating directly with each other like peer to peer. It's
Mm-hmm.
they're both communicating with that central durable object as being that's sort of what we call in SQLSync terminology, I call it like the authoritative version of SQLite. Like it's the authoritative database.
Okay. So in other terms, would source of truth be right?
Yeah.
Okay. So let me say it back to you to make sure I have it. So it sounds like PartyKit is similar but different. It sounds like PartyKit primarily sends and receives messages. Was that close enough, you think?
I think that's a more or rather like PartyKit is more general than SQL Sync in the sense
Okay.
that you take PartyKit and that provides a nicer and like easier to use thing than Cloudflare durable objects for
Okay.
initializing these like shared objects and making it easy to connect to them and managing all of that. And
Hmm.
then you sit your app on top of that, and you need to provide your own data structures and your own message types, and you need to provide your own
Got it.
conflict management and all of these different aspects of multiplayer.
Okay.
SQL Sync
Okay.
SQL Sync technically could be built on top of PartyKit, I guess is a good way to
Got it.
say it.
Okay. So then maybe it's more accurate to say PartyKit is a little bit lower on the abstraction tree, and SQL Sync is a little bit higher and handles more for you. Is that right so
Yep.
far?
Yeah.
Okay.
It's
So
like
then
more
on the
more opinionated, basically.
okay, then on the SQL Sync side, you also rely on a durable object as the authority or the source of truth, and then presumably you've got SQLite databases in the browser that's doing some sort of local first stuff, and then coordinating with the source of truth to then have that be distributed to the other browser or browsers.
Yep.
Is that close?
Yeah, exactly. So
Okay.
now it comes down to the question of like how do you do that coordination? And that's a
Hard.
big aspect of
Hard.
the
Yeah.
multiplayer space.
Yeah. Okay, so I think I have a little bit of the lay of the land architecture stuff. So how do you do that coordination? Like that sounds like honestly, this whole like local first discussion that has been going on Twitter that is just very it's very tiring. But local first seems really hard because then you have two potential sources of truth and maybe n many if you know a bunch of people are connected and writing stuff to the database. Then how do you do the conflict resolution? I know there's like proper, you know, computer science algorithms for it, but tell me for an accounting major, how do you do conflict resolution? That seems really hard.
Yeah, it is super, super hard. So there's so many different ways to address this topic. And so feel free to like stop me and ask me
Okay.
clarifying questions as I go, because it's a pretty complicated and I would it's not even just complicated. There's a lot that is involved with conflict
Mm-hmm.
handling, right? So the first thing that I think is important to talk about is in my mind, I split up conflict management into like two categories, like two sort of broad categories. And I call them, I don't know if this is the best term for it, but it makes sense to me, so I'll use it to explain it.
Mm-hmm.
I call them like physical conflict handling and logical conflict handling.
Okay.
So physical conflict handling is conflict handling that ensures that the data structure that everyone sees
Mm-hmm.
is not corrupted.
Okay.
So
You said physical conflict handling ensures that the data structure that everyone sees is not corrupted.
yes. So I'll
Okay.
give you like a simple example of that. Um, okay, wait, let me actually think of a good simple
Yeah,
example.
yeah. Make it simpler. Make it simpler.
Yeah. Man, like all the simple cases are like so simple that they're almost not that instructive. Uh, but
Does let me ask you a clarifying question. Does structure you were careful to say the data structure is not corrupt? Does that stand opposed to something else? Is it the data that you count as logical conflict? So physical is structure and logical is data?
yeah, sort of. So I guess a way to say this is like, for example, let's say that we have a like a set. A set is just
Okay.
it's like a list without an order. We don't care about the
Mm-hmm.
order. We just care about the contents of the set.
Okay.
So like let's say we have a set data structure, and that data structure is like if you're using like JavaScript and you're just doing basic web app programming, it's probably just represented as like a JavaScript array, right? Or a
Okay.
JavaScript map, depending on how you manage your set. So
Okay.
it's a super simple data structure. And like if we are trying to get to a consistent view of that set, so like you and I have two different versions of the set, and we want to get to like the same version of the set. There are
Okay. Can we
two.
can we make it concrete? Can we say I have some items and you have some items?
Yep,
Okay, so Aaron has items A and C, and Carl has items A and B. Is that a fair starting point?
that's a great starting point. So I have
Okay,
A,
so I
B,
have A
and
and
you have A.
C, you have A, B. Carry on.
So given that sort of starting state, um, like when I talk about physical sort of correctness, let's say that like just we're gonna implement like a very simple set algorithm. You're just
Okay,
gonna send your whole set to me.
okay.
So I have AB and you have AC. So you send me AC, and I look at my two sets. I have AB and AC, and I
Mm-hmm.
like merge them together, right?
Okay.
And now I have ABC. I see the full set of both
Yep.
of our sets. Um, there are two things that are happening in that merging though.
Okay.
That's very subtle. One thing that's happening is like there's an actual like data structure manipulation where I'm manipulating the JavaScript data structure, which is like I have an array on the left side, I have an array on the right side. I'm iterating through the array and like checking to see which objects
Mm-hmm.
are not contained and moving them in, right? There are physical operations happening. And then there's a logical operation, which is when I'm merging these two things, I don't want to end up with B, B, C. I don't want to end up with that. I
Right.
want to end up with A,
Okay.
B, C because it's a set.
Okay.
So that's what I mean when I'm talking about physical and logical. Physical is like the actual act of manipulating the data structure,
Uh-huh.
and logical is like the act of enforcing business logic.
Got it. So let me see if I got this. Physical would be putting the two sets together. Logical would be looking at that result and saying, hey, AA is nonsense. Those were similar items in the discrete sets. And when we put it together physically, potentially, we got AABC, but then we add the logical part, and it's like, come on, y'all. ABC. Let's do
Exactly.
ABC. Is that right?
Yeah, that's exactly right.
Okay.
So okay, so that's in my mind the distinction between like physical and logical. And in
Okay.
that
Love it.
example, it's like so simple that it's almost like not that interesting. But let's talk about a relational database. So I think
Okay.
probably most people watching your shows and your
Mm-hmm.
channel and stuff are familiar with like relational databases, but
Mm-hmm.
generally you have tables, which are basically like sets, interestingly
Mm-hmm.
enough. Um, and you have tables, and one really common thing that exists inside relational databases is like a foreign key. So you have
Mm-hmm.
a table A, table B, and like a row in table A references a key of a row in table B,
Okay.
right? So that's a foreign key relationship. Um, when we are like when we are implementing a multiplayer system for something like a relational database, we have to ensure that when a client, so like let's say that I have my version of the database, you have your version of the database. When we
Okay.
are manipulating these two databases, we have to ensure that two things are true. One is that my my physical database never becomes corrupted. Like if it's SQLite, SQLite has a internal file format, storage
Right.
format that's quite sophisticated. There's like B trees. There's a lot of internal pointers. There's a lot of
Mm-hmm.
like pretty low level sort of things that have to be correct. Otherwise, SQLite will just be like, I don't know what this is. Like it's just a
Yep.
bunch
You
of bytes.
mucked it up. I can't open it. Game over.
So this is the physical side of like
Okay.
multiplayer. We have to make sure that no matter what happens, that whenever you or I look at our database, it's always in a correct and consistent state from a physical
Okay.
perspective.
Seems important.
That's sort of the first aspect of multiplayer. The second aspect of multiplayer is we also want to ensure the logical correctness, i.e.,
Mm.
if I have a foreign key that points at like something else and that thing doesn't exist, that's like a logical error, for example.
Yep. Okay. Love it.
And so going back to the original the source of this question is just like how does SQL Sync work and
Mm-hmm.
how do you implement multiplayer on data structures? The reason why I went down this like very long tangent now that I like think about it is that
Hey, listen, we got all the time in the world, and this is great so far. So
okay,
don't be
cool.
shy. Keep going.
So the reason I went down this tangent is because I actually believe it's very important when you're reasoning about multiplayer systems to think
Mm-hmm.
about these two things as like separate things that both have to exist, but
Okay.
you need to like be able to reason about them separately because achieving physical consistency may not result in achieving logical consistency.
Right.
And so you may need like another layer on top to like achieve that logical consistency. Okay,
Okay.
so that's aside number one.
Mm-hmm.
So
Oh, there's more.
so now I will talk about how I think the next logical thing to do is talk about how SQL Sync actually does the replication aspect, like the multiplayer aspect.
Please.
And then I think probably from there might be some interesting things we could talk about like other systems and how they differ from SQL Sync.
Great. Love it.
So SQL Sync, again, going back to like my original goal of SQLSync, I wanted to make something that was hopefully easy to reason about. Now, any multiplayer system is not easy to reason about, but I wanted
Correct.
to try to keep it like as simple as possible. So SQLSync models the distributed state as every single. So I'm gonna let's give things terminology so we can talk about them because
Mm-hmm.
I don't have many slides to show. So this
Mm-hmm.
is
Yeah,
just
yeah,
gonna be
yeah.
like in our head. So we're gonna call the code that is running inside like a web browser tab, we're going to
Okay.
call that the SQL Sync client. So the
Great.
client is going to be like the code that's running like on your computer.
Okay.
And then we're going to call the code that's running in the Cloudflare durable object the
Mm-hmm.
SQL Sync coordinator.
Coordinator. Cool. Love that. Great
Okay?
name.
So we have a
Yep.
client, we have a coordinator. And
Mm-hmm.
the goal of the client is to
And can I
provide
pause real fast? You could have potentially n many clients connected to one single coordinator.
exactly.
Okay, carry on.
And actually, I'll clarify even one more thing, which is every coordinator maps one-to-one to a SQLite database.
Every coordinator maps. Okay, so every coordinator has one SQLite database that is the authority,
Yep.
and that is part of the coordinator's purview is keep the authority, and then all of the clients connect to that coordinator that is sitting next to a single SQLite database
Yes, exactly.
or
So
has it
if
within
you
it or
like
whatever.
as
Okay.
a web browser tab, like let's say that you wanted to open two different SQL Sync databases.
Mm-hmm.
In this case, you would be connected to two different SQL Sync coordinators.
Got it. Okay.
Each coordinator manages one SQLite database, basically.
Cool. Love it. All right. Perfect. Keep going.
Cool. So we have this coordinator up in the cloud somewhere, some serverless magical thing,
Of
and we
course.
have our local client. And then both you and I have a local client because we're like, let's say going back to the to-do list thing, we're both working on the same to-do list. That
Okay.
means that we're both connected to the same coordinator.
Mm-hmm.
Now, SQL Sync, we'll just talk about like the basic replication flow. So the first thing that happens is like, let's say that I add a to-do in my local SQLite database.
Let's make it groceries. We're sharing a grocery list.
Sure.
We're best friend roommates. So you add milk. Great.
Great. I add milk to my local SQLite database.
Mm-hmm.
So the first thing that happens is that SQLite just straight up commits that and just shows me right away. Like no network connection at all has happened.
Okay, so in the client, in the actual browser, you've got a SQLite database that has milk written into it.
Bingo.
Okay.
So SQL Sync's first and primary goal is committing that to the local state, like durably, in the
Mm-hmm.
local client, and then immediately showing that to the code so that the client can
Okay.
render it. So there's no need to have any kind of like in a lot of like front end like React code, for
Mm-hmm.
example, or Vue code, you would have your like your database state over here, and then you'd have like your client side cache code, right? So the whole
Yep.
idea is we eliminate that client side cache. You can synchronously query SQL Sync and get back that milk right away.
Okay. So you have in this architecture, you have achieved local first in that you type in milk enter, boom, it's immediately in the UI. Now it could, and we haven't gotten there yet, but it could take a second to get out to Cloudflare and to the other person. And if that fails, presumably you do something in the local UI. But local UI is immediately updated, so you have achieved this panacea of local first that everyone is after. Is that good so far?
Yep, that's exactly right.
Okay. All right, carry on. What
Cool.
happens next?
So now SQL Sync's happy. It's like, all right, great, we've committed this thing. But it does it in a little bit of a tricky way. And this is where the first aspect of where
We
SQL Sync
love
is
we
not.
love trickies. Yes,
Yeah,
this is
so
great.
the SQL Sync uses regular SQLite, but SQL Sync
Okay.
tricks SQLite. And what
Yep.
it does is what I did is I implemented a VFS. VFS for
Yeah, you
SQLite is
did.
a virtual file system.
Yeah.
And so when SQLite goes and tries to like write to the disk, it thinks that it's
Uh-huh.
like writing to like a normal file system, but
Uh-huh.
my VFS code tells SQLite that it's like it handles all the writes on behalf of SQLite, and it just
Mm-hmm.
does some magical things, and it tells SQLite it's all good, like you're good. We have the right, you can read it, it's all good.
Okay,
Um,
so let me pause there for people who aren't in the internals as much as you are. The architecture of SQLite is such that there's a bunch of stuff on top, virtual machine. When you finally get to the bottom, it has to write to the disk. It's pretty important. And the way that is implemented in SQLite, to my understanding, is through this. There's this abstract layer called the VFS, and then there are two concrete implementations: one for Unix system, one for Windows systems, and then everybody has their own. Three. What's the third?
Memory.
Memory, yes. Okay, perfect. So you have these three that are concrete from DRH himself, SQLite guy. But you can totally write your own VFS, which is what I thought Lightstream was, but that's not the case. So you have written some sort of VFS that conforms to the interface. So SQLite is happy to hand you data and trust that your VFS is good, and you do something with that data. And so this is kind of like one of the ways that you can modify SQLite is you just kind of sneak in there and you're like, I'm writing to the disk now. Give me all the data. Is that right? Hey, I hope you're enjoying this. Just as a reminder, you can learn more about SQLite at highperformancesqlite.com. I'll get out of your way. Back to the interview.
Yep, exactly.
Okay.
So my VFS presents like if just like a little aside on the VFS stuff because some of
Yeah.
your viewers might find this sort of cool. So SQLite VFS looks like a sort of when you implement it, you're basically implementing like a Unix file system abstraction. Like you
Mm-hmm.
have the ability to like create files, delete files, um, truncate
Read and
files.
write. Yeah.
I don't even think you can rename files. It's a very simple file system abstraction. And then once you have the file handle, so like you give SQLite like this file handle thing, which it just thinks of as this like opaque blob.
Mm-hmm.
And this file handle has all your normal file system operations, like writing to the file, reading from the file, and so on, right? So it's a very simple abstraction. And so what the SQLSync VFS does is it actually internally maintains um, this. It's like a layered file system basically.
Okay.
So it maintains what it calls the like snapshot,
Mm-hmm.
which is a snapshot of the SQLite database that has been fully committed on the authoritative coordinator.
Okay, so ooh, that's good. Okay, so hang on. So the VFS knows somehow through communication with the coordinator, um, it has some sort of high watermark of this has been committed into stone and you can trust it.
Yes.
And then
So
beyond that is like the pending or something.
exactly. So like if you think about the first time you like load the web page, so you load the web page
Mm-hmm.
like the grocery list app, it has no database. But let's say that we already had been using this database for a while, so it has a bunch of
Mm-hmm.
grocery list items. The first time I load that app on my like phone, for example, it's going to download that SQLite snapshot, boom,
Mm-hmm.
locally. So it has a full copy of the database as of some like known authoritative point.
Okay.
And so that's its snapshot, and that's where it's going to start from. And then when I go into the app and I say like create new grocery list item, add milk, it's going to internally the VFS like when SQLite goes and writes pages into the file, so it tries to
Mm-hmm.
edit the SQLite file, it's going to keep those edits to the file as like a separate layer. It's going to present to SQLite like when SQLite looks, it's going to just see one file that's just contiguous.
Mm-hmm.
But internally, I sort of split it out into snapshot and then like all the edits, like local edits, basically.
Okay, hang on. So you have your snapshot that you can trust, and then somebody writes eggs to the to-do list or the grocery list. Do you write are you keeping track of like do you go ahead and write that to the SQLite database just in like a normal form and then write it aside to a pending changes file, or is there some way in the SQLite database that you mark it as not committed or pending or whatever?
So I do store some information about the transaction that was executed, and we'll talk
Mm-hmm.
about that as well. But internally, like on the file system abstraction side, the file system just keeps like the last authoritative snapshot, which is like the base version of the file, and then it just keeps track of like all the edits to the file. And these are just like
Okay.
raw edits to like the bytes of the file. It doesn't even know what those edits are. It just treats them
Got
as these
it.
like
Okay.
opaque changes to the file.
So it's
Um,
almost like a bin log that's is that right?
It's not even like a log because it simply has like two layers. It just has like snapshot, which is at like version one, and then it
Uh-huh.
has like all the changes to that version as just
Okay.
like essentially like a sparse page map, essentially.
Okay. Okay. All right, keep going. Keep going.
Okay, but the
All right.
reason that SQL Sync does this and like the value of this, like why is this valuable? It allows SQL Sync to instantaneously roll back to the snapshot. Like all SQL Sync does is
Yeah. Okay.
drop this like layer of like
Yeah.
all your local changes, and it's instantaneously identical to the original snapshot from the server,
Yeah.
right?
Okay.
And this is a very cool property that we're gonna need for like a later point.
Okay.
So
Love it. That's good foreshadowing. I love that. Yeah.
okay,
When are we gonna need it? All right, keep going.
so what we've established so far is like when we add milk to our grocery list,
Mm-hmm.
we are doing regular SQLite stuff. SQLite just runs the
Mm-hmm.
transaction just like normal. SQLite sees like a normal file system and writes the change to the normal file system like nothing has changed from SQLite's perspective. And all
Mm-hmm.
we've done internally is we've just sort of tracked this was like the last version of the database that we like know is fully consistent and shared with the authoritative state. And then here's all
Mm-hmm.
like the local changes that have happened. So now the question is, what's next? So what's next is let's talk about transactions.
Mm-hmm.
So regular like relational transactions, you have like your begin, insert one row, insert two rows, select whatever, commit, right? This is like how relational databases work. SQL Sync has a transaction system that it forces you to use. So one thing about
Okay.
SQL Sync that is weird is you can't just write directly to SQLite. Like it doesn't give you like a normal like SQLite connection handle that you can just use and run an insert command.
Okay. That's interesting.
Instead, it forces you to, and this is a design decision that's specific to SQL Sync. It's not necessarily the perfect design decision, and it's something I'm going to change in the future. But let's just say what it does right now.
Okay.
What it does is it forces you to write all of your transactions in WebAssembly.
It forces you to write all of your transactions in WebAssembly. It forces who to write their
You, as in the
transactions?
developer of the app.
Okay.
So, as a developer of an app who uses SQLSync,
Uh-huh.
you write what SQLSync calls like the mutator. And
Okay.
the mutator is essentially a WebAssembly blob, like a blob of
Mm-hmm.
WebAssembly code, which you can compile from Rust or other languages that support WebAssembly.
Okay.
You write some code, you compile it to WebAssembly, and this blob implements an API. And on the input side of the API, the side that your app sees,
Okay.
essentially it looks like almost like a normal web API. Like if you think about implementing like a REST API or like a GraphQL API,
Mm-hmm.
on like the input side, it's just a bunch of handlers. So for example, in this grocery list app, we would have like add grocery item, remove grocery item, you know, all of our any type of endpoint in our app that
Mm-hmm.
is changing the state of the system.
Okay. Okay. I think that makes sense. So if I'm the developer and I'm writing the add grocery item endpoint in air quotes, what am I talking to if not a raw SQL connection or raw SQLite
So
connection?
I guess I was a little bit overly aggressive about that. Inside your WebAssembly code, you get like a
Mm-hmm.
completely normal SQLite connection.
Got it. Okay.
It's just that
Okay.
you can only access that SQLite connection from inside this WebAssembly object.
Got it. Okay. So you have this concept, this firewall concept where this, what did you call it? The mutator.
The mutator, yeah.
The mutator is allowed to talk to the SQLite database, whereas the application code must talk to the mutator.
Exactly. And so,
Okay.
like, if you actually look at when you're done with building your app on top of SQL Sync, when you look at the code, it sort of looks like all your mutations are just like hitting like a web endpoint, very similarly to how they
Cool.
would look if you were using like a regular web server.
That's kind of cool. Okay.
So maybe I need to name these things differently. I think the mutator thing is throws people
I
off.
I don't know. I mean, there's a lot to learn, and I think I'm following so far. So I think you're
But
doing okay. So carry on.
yeah, so basically we have this mutator, which you can think of as just like a really lightweight API server because it's this
Mm-hmm.
WebAssembly blob and it can run like because it's WebAssembly, we can actually just run it directly inside of the client. So it's almost like we've brought like our API layer, the part of our API layer that is able to mutate the database. It's almost like we've
Mm-hmm.
teleported that down into the client. Um,
Okay.
so
Why must it be in WASM?
It doesn't really have to be in WebAssembly in terms of like all of the ways I could build this.
Uh
The
huh.
reason why I chose WebAssembly is a couple of things. The first thing is that the mutator logic has to run on both the server and the client, and we'll talk about that in a little bit. But basically,
Both the
like
coordinator and the client.
yes, it runs on
Okay.
the coordinator and runs onto the client. And so we needed a portable, like an
Oh.
easily portable sort of abstraction for this like
Okay.
arbitrary code that the developer is
Mm-hmm.
writing. I could have used JavaScript. I think that would be like the other logical choice because we can run JavaScript on the client, we can run JavaScript on the
Sure.
server. But the reason why I went with WebAssembly is because JavaScript is harder to bundle in like a really clean and like sort of sanitized way.
Boy, isn't it? Okay. That makes a lot of sense. Okay.
Whereas
Cool.
WebAssembly is sort of naturally bundleable. Like you get like
Right.
one WebAssembly object, like you're done. That's the
Mm-hmm.
bundle. And I know that I don't have to worry about sandboxing. I don't have to worry about anything. It just is this nice like opaque blob that I can treat as an API.
I don't want to jump ahead, but I think I see where this is going. If the mutator must live in the coordinator as well. But
Yeah.
all right, so keep going. So now we've got a SQLite database in the client. We have this firewall that is this WebAssembly mutator, and then on the application side, the application code speaks to the WebAssembly thing as if almost as if it's an API, but it's all right there. It's all local. It's all in the client, and then that mutator talks directly to the SQLite database.
Yep.
Okay.
So if we sort of visualize what that code looks like in the client, so I go click on like the add grocery button, I type in like milk, I hit enter,
Mm-hmm.
that is literally going like in my React code or my Vue code is going to be
Mm-hmm.
calling that mutator, which is like add grocery item mutator in my WebAssembly
Mm-hmm.
code.
Mm-hmm.
And that internally is going to run a transaction against SQLite. It's going to mutate the database, and that's what happens like locally. So then
Okay.
what SQL Sync does, and this is the fun part, is that we
Okay.
record in a log, we record that we ran add grocery, like the add grocery mutation.
Mm.
And all we have to store is essentially the name of the mutator in the WebAssembly object,
Mm-hmm.
and then all the arguments to the mutator,
Mm-hmm.
right? So we just have this relatively like lightweight log. And this log actually could be potentially represent very large changes to the database. Like you could have a mutator that said delete everything. You could have a
Mm-hmm.
mutator that said like add 1,000,000 rows to the database. So
Sure.
the change size doesn't actually relate directly to the like mutator
Mm-hmm.
size. And
Totally.
that's sort of a nice property. You can think of this mutator log as essentially a representation of all of like the business logic transactions that happened on your app.
This almost feels like event sourcing where you're just keeping track of the events to later replay
This
them.
is exactly event sourcing, actually.
Yes.
So you
Love
nailed
it.
it.
I was hedging. I was hedging. I didn't want to come in too confident.
Yeah, I guess exactly is probably not right, but it's very very close.
Oh, don't walk it back now. I was right. I was exactly right.
Well, I have to walk it back because I know this is going on the internet, and like
Yeah,
sometimes you'd be
that's
like
true.
you're
Good
not allowed
point.
to say exactly.
Good point.
Okay, so basically we record this log locally that says, okay, like Aaron on his computer said that I'm going to add milk, and then he said I'm going to add eggs, then he said I'm going to add whatever. And this is just a
Mm-hmm.
local log. Again, we haven't hit the internet network yet. When your computer has network access, your computer is going to connect to the coordinator,
Okay.
and it's going to send the log of all the mutations you did on the database.
Okay.
Just the log. It doesn't send any
Mm-hmm.
changes you made to the database. It sends the like description of the changes you made to the database, i.e., the like
Okay.
list of mutations.
So to clarify, there are two. As far as I understand, there are two sets of like uncommitted changes. We'll say in the SQLite database, you have a high watermark of what is committed by the coordinator. Then you have other stuff on top of that. But that's not what we're sending. What we're sending is a stream of names of functions and function arguments to be replayed by the coordinator.
That's exactly right.
Okay. All right.
So now the coordinator is connected to both of our computers, let's say. So it's connected to my computer, it's connected to your computer, and both of us are like anxiously adding all of our grocery list items for the upcoming week because like we know
Yep.
we need to go to the grocery store. And
Yep.
so the coordinator receives this like completely random list. Some of the items come from Carl, some come from Aaron. And what it has to first do is it has to decide on some ordering of all of these mutations.
Mm-hmm.
And so the server, the coordinator, has the advantage that it's like a single authoritative sort of state. And so
Yep.
it just decides on the ordering is based on when it receives each of these mutations.
Okay.
So it has its own global log, and that log contains all of our mutations put together into one log, ordered by whenever it was received by the server, by the coordinator.
Okay. So there's no timekeeping in the clients.
Exactly. So the client
Okay.
doesn't need to worry about time. We just send the transactions as we create them, or the transactions, the mutations as we create them
Mm-hmm.
to the coordinator. The coordinator simply orders all the mutations into this global log that is per database that it manages.
Cool. Mm-hmm.
And then what it does is it just simply applies that global log using the same WebAssembly object that we're running inside our clients
Mm-hmm.
onto the SQLite database. And so it's essentially building a new version of the SQLite database that contains all of my changes and all of your changes.
Mm-hmm.
And we'll talk about this is a good time to talk about conflicts because this is exactly where
Yes.
conflicts actually is going to happen, right?
Right. So if you're offline for 20 minutes and I'm not offline and I add milk, but I remove eggs, and then I don't know what the conflict there would be.
Yeah, it turns out grocery lists are really easy to do automatic
Yeah,
conflicts.
shoot. Let's say I change the name of eggs to eggs parentheses 2 dozen,
Yeah.
and you delete eggs. Then what?
Yeah, exactly. That's a pretty. We can start there, and then we can add more more complex conflicts later.
Okay.
So this is where we can talk again about this. Like, why did Carl talk about physical and logical conflicts? Like, why does that matter? So
I just thought it was interesting, but sure,
yeah.
tell me why.
It is interesting. I mean, I'm a huge nerd about this stuff, so this is super interesting to me. But because we've ordered like all of the mutations globally on the coordinator, and the coordinator just runs like one mutation at a time
Mm-hmm.
against the SQLite database. We've
Mm-hmm.
eliminated the possibility of there to be any kind of like physical conflicts in the SQLite database because
Okay.
SQLite knows how to handle running one transaction at a time. If
Mm-hmm.
we can represent the transaction in SQL, SQLite guarantees that it will not corrupt the database, right?
Correct.
Now, this would be at odds with like a naive version of multiplayer would be like, I'll just edit the database and you edit the database, and let's just exchange all the changed like low level pages, like the actual
Mm.
changed bytes in the database, and
Yep.
let's just hope that it works. In this case, we'll probably corrupt the database very quickly because we're just like
Yes.
exchanging like random bytes about a file. Hilariously, SQLite will actually handle like a lot of changes this way without corrupting, but there will be a bunch of changes which it can't handle. Like for example, it
Mm-hmm.
moves a B tree around or it changes certain things.
Vacuums
Um,
something up on one
exactly. There's a whole
side.
bunch of
Yeah.
changes that could happen, which exchanging all the edits we did would involve physical corruption. So the first thing that SQL Sync does really well is that it completely solves physical corruption by just basically guaranteeing that there's like a single writer. There's only like we're writing
Mm-hmm.
each of these transactions in order in like the coordinator. We can eliminate any kind of like physical conflict corruption.
Yeah, and you're staying outside of like the realm of danger. So you're just like interacting with SQLite as it was made to be interacted with. You're not mucking about with the bytes in the file.
Exactly. So then there's the logical conflict. So the logical conflict that you described, which is like basically you change the name of a grocery list item and I delete it.
Mm-hmm.
That conflict like needs to be decided. Like what happens in that case is a
Mm-hmm.
decision that the developer has to make. That is fundamentally a business logic decision. We can come up with a
Hmm.
bunch of different solutions, right? One solution would be the last writer wins, right? Like if
All right.
I delete and then you edit, your edit just
Mm-hmm.
disappears because or potentially we want the edit to like restore the item, right? I
Mm-hmm.
deleted, then you edited. We want that edit to like bring the item back.
Right.
Potentially we want to do some kind of like weird merge, although you can't really merge edit and delete. But let's say we both edited the title at the
Mm.
same time.
Okay.
The merge would be like let's look at the titles and then let's like merge them together in some way.
Okay.
Right? This is fundamentally a business logic decision. Like it's something the developer has to decide, and the decision is going to have a lot of trade-offs. Like some of those decisions are going to be much more efficient to implement than others. Like last writer wins is probably the most efficient. Just overwrite whatever's there and move
Mm-hmm.
forward. Whereas some kind of like conflict detection, which involves some kind of like three-way merge or some kind of like
Mm-hmm.
more complex thing, is going to be more sophisticated. SQL Sync allows the developer to manage that themselves inside of their WASM, their WebAssembly logic. The
Okay.
reason we use WebAssembly instead of just having we could just express the mutations as just simply SQL commands, right? Like, why do we need to
Sure.
add the WebAssembly layer? We add the WebAssembly layer because that layer is where you logically should handle mutations or
Okay.
conflicts. Sorry.
And
So
you need some sort of programming language to do that.
exactly.
You can't
So
just
you need
have
to like
SQL
encode the
inserts.
business logic of conflicts
Mm-hmm.
somewhere into the system. And SQL Sync does that by allowing you to encode that into your WebAssembly program that you write.
Okay.
And so your WebAssembly program, which let's say that it handles, has a rename operation. And let's say
Okay.
that it sees that you as the developer want to encode the property that a rename operation should like restore an item back from the dead if it was deleted.
Okay.
So in order to implement that in SQL Sync, you'd have to implement, first of all, you'd have to keep around the state of a deleted item. And so traditionally
Mm-hmm.
in most relational systems, the way we do that is that rather than deleting a row, we just have a column which represents that the row was logically deleted.
Mm-hmm.
So your delete operation would simply be mark that delete column to be true, and your rename operation would be
Oh.
rename the column and then also mark that as false if it was marked true.
Okay, so hang on. Um okay, so I as the developer have to anticipate that one possibility would be that I rename something that you have deleted. And in my knowing that that is true, I would have to modify my delete mutation to tombstone it or like soft delete it or something. And in my rename operation, would I in my rename operation always rename it and set deleted at to
Yep.
null, or is there some sort of conflict method that is called, or all of the, like, does the rename setting the deleted to null, does that handle the conflict itself? Do you see what I'm asking? Like, is there a on conflict callback?
Yeah, so there's no on conflict. You just implement the conflict management in pure SQL, and SQL is
Got it.
pretty good at managing this type of conflict. In a more complex type of conflict, where, for example, let's say that I rename a column and you rename a column,
Mm-hmm.
and we do it at the same time, and the question is like we want to get like a merged version of those two
Yeah.
things. You would have to add some additional metadata to your data structures, like to your actual tables, to be able to
Mm.
help your mutator know when it should perform like a merge and when it shouldn't perform a merge.
Hmm.
But the nice thing is that the mutator is like arbitrary logic. It's
Sure.
basically, you know, um, just arbitrary code. And so the idea is that like you can run a select query in your mutator. Like you can observe the
Oh,
database, you can get back some information about it, and then you can make a informed decision based on that observation.
cool.
Which would be exactly what you would do if you were implementing some kind of basic
Hmm.
multiplayer inside like a traditional application architecture, like a traditional backend API.
Mm-hmm.
So
Okay.
the idea of SQL Sync is to like provide a experience of like writing this like mutator layer that is more
Mm-hmm.
similar to like a traditional API on top of a regular relational database than needing to learn about like automatic like data structures that implement some kind of like automatic conflict management.
Right.
So this is like a major thing where SQL Sync is sort of at odds with like other systems.
Yeah.
Um,
Yeah. So if I'm understanding correctly, um, all of the I think it's important that you said the conflict resolution is a business logic layer, because at that point I happen to agree that some library deciding who wins may not be what I would have decided. May not be what is right for my users or my app or whatever. And so, what the stance that you have taken is that conflict resolution must be handled by the developer. And the way that you do that is by providing this stream of events that can be played locally and at the coordinator. And I guess the code is the same, but it doesn't matter until it gets to the coordinator where it has to do the actual conflict resolution.
yep, exactly.
Okay.
So just to like fast forward to sort of the like full round trip. So far we've essentially both edited the database. We've both sent
Mm-hmm.
our like change streams up to the coordinator. The coordinator
Mm-hmm.
has built like a new version of SQLite, like the database,
Mm-hmm.
that reflects all of our mutations together with conflict
Yep.
handling and everything. So that is like there's this new authoritative version that's like this is the version that we should all see, basically.
Mm-hmm.
So the last step of this is making it so that both of us can see those like new correct authoritative versions and
Mm-hmm.
continue to make changes over time, right?
Okay.
And so the way that last step works is that the coordinator sends down raw changes to the like underlying file that backs SQLite. So this is where
Okay.
we're
Hang on.
actually sending down like physical changes to the SQLite file to each of our clients.
Changes. Okay. So you're sending down raw changes. So it's in the coordinator. In the coordinator, you have the database at a particular state. You receive a dozen events. You play those dozen events. And then do you do a diff of what it was before the dozen events came in? Like what the actual underlying SQLite file was before the dozen events, after the dozen events. And then you send the diff, which is just like a bunch of bytes back to each client?
Yes, we send a diff. The way we produce the diff is very efficient, so we don't have to do like
Okay.
a full diff where we compare the two states of the system.
Uh
Um,
huh.
but basically, yes. Like so, SQL Sync is going to on the coordinator is going to collect essentially the specific set of bytes that have changed between the last time that it sent a snapshot to you and to me. And interestingly, like those two snapshot points can actually be different, and this is a very complex thing because you could like let's say that you came online after I came online, your snapshot
Oh,
could actually be like reflecting a different starting point than mine.
you're totally right.
And so the coordinator actually takes that into account and it builds custom diffs for every single client to be able to
Jeez.
fast forward them as efficiently as possible to the latest version of the.
So does every client send their last known state along with the stream of events, or their last
Sort of.
committed state?
Yeah, sort of. You could think of it that way. Like essentially, the coordinator knows like the last committed, like the last authoritative LSN on every single client.
Okay. And then just for my edification, are you like listening to SQLite somehow and seeing which pages are changed? How are you doing that efficiently? VFS! It's always the VFS. Son of a gun. Okay. Yeah,
So the
forgot
same
about the
VFS that runs on
VFS.
the client runs on the coordinator. The coordinator's VFS does a slightly more sophisticated thing, which is that it sort of tracks changes as a like a log of changes, like a series of diffs to the say SQLite file. And then it can use that log to be able to efficiently
Of
build these like
course.
delta records to send to different clients.
Of course. That's awesome. Okay, so then at that point, the coordinator has a diff, a change set that could be sent to Carl and Aaron, and those could be different,
Yep.
but they are correct for the clients that are connected.
Yep.
Then what happens?
Okay, so now you're a client. So like think about your computer. Your
Yep.
computer actually has three different versions of the database at that point when it receives the diff from the server. It has the original authoritative state from when you started.
Yep.
It has local changes to the SQLite file that you've made. And then it has remote changes that the coordinators made that may actually reflect other people's changes that you don't even know
Sure.
about,
Okay.
right? So you have sort of three different versions of the database file. And the way that SQLSync works, and this sounds really insane, but it totally works, is
This all sounds insane, but I love every little bit of it. So yeah, tell me the insane part.
all right. So this is the insane part. The insane part is basically SQLSync performs like a rebase operation. It's very similar to like how Git rebase works. So step one is we throw away all your local changes. So
Naturally.
temporarily, SQLSync rolls back the database to before you changed anything. So now there's only
Which rolls it back to the last authoritative state from the coordinator.
yeah.
Okay.
So it rolls back to the last like version that we started from before we made any local changes. Like the last state we know is correct. Then what it does is it fast forwards to the coordinator authoritative version. So now it just has one version of the database. It has the new authoritative version. And then what it does is it needs to basically so locally on your computer you have a series like you have a list of mutations. And some of those mutations have been applied by the coordinator. And some of those mutations are still pending, like they haven't yet been applied. Maybe you made them really, really recently, or they're just like they haven't been processed yet on the coordinator.
Okay, so hang on. You're saying that the coordinator sent me back a diff, and I've got 10 mutations, and 5 of those may be represented in that new stream of bytes or that new diff. But it's possible that between the time the first 5 were sent off and handled by the coordinator and come back, I've written 5 more.
Exactly. So to make this like more concrete, like let's say that you add like eggs and then you add milk and then you add broccoli, right?
Yep.
So the coordinator you send like just because of everything is happening concurrently and in parallel, so it's all happening at the same time. So you send to the coordinator eggs and milk, but you haven't sent broccoli yet. So broccoli is still sitting there in your like outbound queue, right? But you know that I have all these 3 mutations. Like these 3 mutations matter to the user. I can't suddenly make like eggs disappear. I have to continue to show it. So we send those 2 mutations, eggs and milk, to the server. The coordinator applies those mutations and then sends us back a diff of the database. And that diff of the database now may include eggs and milk, but you don't know if it does yet. So
because it wasn't what was sent back was not mutations. It was a diff of an underlying file that's
and it's basically
opaque.
Completely opaque. Like we don't look at this thing. We just sort of treat it as like bytes. We apply it to SQLite, and then the question we have to ask the question is like, of those 3 mutations that we had, we have eggs, milk, and broccoli. Were any of them are any of them applied? Like, are any of them committed in the authoritative version? And the way that SQLSync does this, and this is an idea that I came up with at SingleStore when I was like working on some projects that they have there, and it applies really well to SQLSync. So what this is that SQLSync on the coordinator when it applies mutations, so the mutations are editing your database, right? Like they're adding milk, they're adding eggs to your database. In addition, SQLSync implements adds a hidden table inside SQLite. It's a regular
Hell
SQLite
yeah.
table,
Yeah.
and this table has one row per client that has ever worked on the database.
One row per client. Okay.
So we're both connected to the same database. That
Mm-hmm.
table will have two rows. One
Okay.
represents Carl, one represents Aaron.
Mm-hmm.
And that row just simply records the client ID and the highest sequence number from that client, like the highest mutation ID from that client.
So importantly, every mutation has an increasing
A
ID.
monotonic ID, yeah.
Monotonic. There it is. Okay. So I send off IDs 1 through 5. And at the coordinator level, you update. The last one that I saw was 5 for Aaron.
Yep.
Then you send me back the diff, which includes the secret hidden table. And so then if I'm jumping ahead, the diff is applied. So all my local changes to the actual database are thrown away. My mutations are hanging out. You apply the diff. Then I'm guessing we inspect the secret table and say, this is committed state at the coordinator. You can trust it. The last the last mutation that the coordinator saw was number 5. So we'll truncate anything below or 5 and below, and then replay 6 through 10 locally and send them off.
Bingo.
Hot dang. How about that? That is pretty freaking cool.
And that is a full end-to-end multiplayer relational database.
Wow. That is very awesome, I must admit. And it's not simple, but it's straightforward.
It's pretty straightforward.
That's a good, I don't know anything about these systems, but that's a good one. That's a great one.
Yeah, what I like about it is that it's I wanted to try to keep this again. My goal is I want vanilla SQLite, right?
Sure.
So if it's vanilla SQLite, I can't change how SQLite represents its internal data structures, because if I do that,
would you want to?
vanilla,
yeah.
Right. So if I want completely vanilla SQLite, I need all of its internal data structures, how it stores data, how it manipulates B trees, how it does all of that management
Right.
has to be vanilla, unchanged. And so I knew by definition, I couldn't manipulate the physical layer of SQLite. So I have to keep that. And then the second thing is how do you implement conflicts? And you can do logical conflict management where you actually add a layer between the user and SQLite, and and basically you have to process all of the writes yourself, and you have to basically logically do your own sort of writes to your own tracking data structures and then forward them to SQLite. You act it as an intermediary between the client and SQLite. And I didn't want to do that either, because I wanted to expose a raw SQLite transaction API to the user. If you want to use a SQLite extension, you can install it into SQLSync and use the extension. There's nothing about it that knows literally anything about your data. It's completely opaque to SQLSync. And that was the goal. So I basically built all of the things, all of the trade-offs that SQLSync has, and all of the things about it that are interesting and unique are all driven from the fundamental goal of completely vanilla SQLite. Your app should mostly feel like working with regular SQLite.
This is something I feel like keeps coming up when talking to people about SQLite, is they don't necessarily want to touch SQLite. And I feel like a big part of that is, one, SQLite is very good, but two, SQLite is incredibly stable.
Yeah.
And so to get in there and start dorking around with the pages yourself, frankly, that seems very risky to me, because, they've spent, 24 years now making it super stable. And so it seems like a lot of people are coming at it from the outside. You've got your VFS, Lightstream has its little sidecar that's keeping a transaction open and kind of sneaking into the wall file and mucking around with that. And I really it seems like it almost seems like a fun challenge. How can I do everything I want without opening this black box?
Yeah.
And it sounds like you did it, which is pretty awesome.
Yeah, it did feel really cool. Like SQL Sync, I'm really proud of. I think it's a
You
really cool
should be.
tech.
Okay, so tell me, SQL Sync is fully open source.
Hmm.
Okay. And what is the plan? Like, what's the plan for? So is everything you described where you're at right now? All that's handled. All that's done.
Yep. Yeah. So
Okay. So
SQL
what's the
Sync.
plan moving
Yeah.
forward?
So SQL Sync, as of like right now, it works pretty well, but it doesn't scale very well. Like that's sort
Okay.
of the fundamental like limitation of it. One of the biggest limitations of SQL Sync today is that it requires every single client and coordinator to have a full copy of the entire database. And so
Sure.
it works pretty well for small databases, like in the like megs size.
Hmm.
It works great. It's super fast at replicating state. It can, you can handle like relatively high amount of mutations. It's a fairly good system for just small databases. But
Okay.
if you scale up to, let's say, a gigabyte, that's you just automatically a non-starter based on the need to have to sync the entire system to every single device.
So the limitation there is sync time. Is there a limitation of SQLite in the browser?
Yeah, I mean, browsers are pretty limited in like how much they can store.
Hmm.
Like browser tabs, you have memory limits that you're allowed to a certain amount of memory you're allowed to consume as like a JavaScript process or like a web worker process. And then
Okay.
there's also like storage limits. So if you're storing in like IndexedDB or if you're storing in OPFS or you're storing in like any of the different ways of storing data inside the browser, all of those have their own limits. And those limits get pretty bad pretty quickly.
Mm,
And generally, like I try to avoid ever putting like more than like half a gig of data in a browser tab. Once
okay.
you get higher than that, like there are ways you can get higher than that, but it becomes a lot more iffy and sketchy. And it's almost at that point you're like you might as well build a desktop application where you can have like dedicated
Mm,
storage. And you can actually work with the user because there's also the aspect of like most browser storage is
mm,
not even like known by the user as to like where that storage is, right?
mm-hmm.
It's treated as more of like a cache layer than like a durable storage layer. But when you're
Right.
storing like database state that you potentially don't want to lose, you may want to actually know where that is. You might want to be able to back it up. Like you might want to be able to access it out of band. So long story short, the current state of SQL Sync doesn't really scale due to that limitation.
Mm-hmm.
Um, it has a couple other things that I'm not super happy with about it. Those are very, very technical and like very specific to how I implemented it. One
Mm-hmm.
of the things is like I'm not super happy with like using WebAssembly.
Hmm.
WebAssembly is great for systems people, like for low level programmers, for people who are willing to go get their hands really dirty. It's pretty like
Sure.
messy at this point. It's also great for Rust programmers because it actually
Mm-hmm.
has like a nice user experience in Rust. But pretty much everyone else it sort of sucks. So I'm thinking about I'd like to have like more like a JavaScript experience because I think JavaScript has it's just way easier to integrate into your app if you could just write like a JavaScript mutation as opposed
Yep.
to having to like build a WebAssembly module just to implement a mutation.
Yeah.
So those are some of the changes that I want to do. But the short term change, like the thing that I'm working on right now, so basically I released SQL Sync back in like late last year. This year, since January, I've been working basically full time on a new project that I'm calling Graft.
Okay.
And so Graft is a storage engine that
Okay.
will power SQL Sync.
Okay. Go on.
Uh, and yeah, it's the first time I've actually talked about it. So
You don't have to reveal
no,
anything you
no,
don't
this is
want
good.
to.
This is good. It forces me to like put it into words.
Okay.
Basically, Graft is a storage engine that I'm building. What is a storage engine? Like it's essentially it gives you sort of a file like abstraction. Like it's here's a blob, and it lets you read and write bytes to that blob.
Okay.
But it implements the way it reads and writes bytes to that blob. It internally uses these data structures that are very efficient to synchronize over the internet. And
So
so, for
what does this
example,
what does this replace in SQL Sync?
it replaces the VFS layer that I
Got it.
implemented, basically.
Okay.
So the
Okay.
VFS layer in SQL Sync works reasonably well, but
Uh huh.
it was implemented in a very like simple way. Like we just simply have like a layered file system. We track all the edits to the file like at every single transaction point,
Uh huh.
and so it has a lot of duplication over time. Like if you edit the same page multiple times, for example, you'll store like multiple copies of that page. But the clients don't actually need to care about every single version of that page. The client literally only cares to be able to
Right.
fast forward to like the latest version of the page
Right.
when the
Okay.
client synchronizes. So Graft is a sort of special purpose storage data structure that is really efficiently designed to do fast forward replication. So that's its whole thing. And I'm building it as like a low level library that is independent from SQLite and from SQLSync,
Mm-hmm.
because it itself is actually just a useful way to basically say, like, let's say you have a file in point A and you want to have that file in point B. Graft will
Mm-hmm.
do that for you. It will copy it. But where Graft differs from something like, let's say, rsync, is that
Okay.
Graft will continuously replicate changes to that file forever. And it will do so using a close to minimum amount of bandwidth.
Okay.
So that's what I'm building now, and that will eventually power SQL Sync. And also I'm experimenting with using it to do some other really cool things. One of the ideas I had was in the like data science and like AI model space, being able to like
Yeah.
efficiently move like portions of AI models and like specifically like training data sets or like weight files
Sure.
between different machines, and being able to only need to move like what you need right now. So yeah, the other property of Graph that's cool is like it does fast forward replication, and it also does lazy replication. So I
Hmm.
can you can when you're reading from Graph, you can choose to only read a subset of the file. And so in
Hmm.
SQL Sync land, what this means is that I'll be able to run 20 gigabyte databases and have them run inside your browser tab.
Okay. So hang on. Let my brain catch up here a second. So you currently have this VFS that sneaks in, keeps track of stuff. You're writing Graft. Is that does that sit next to the SQLite file, or is that what this is it like a file system itself? Like
Pretty much.
I don't fully understand how it works.
Yeah, so you can think of Graph as providing like uh, it's basically it provides you a file system abstraction
Okay.
without the it doesn't provide the like there's two parts of a file system. There's like the directory metadata tier of the file system, and then there's like
Okay.
the file store. The
Okay.
directory metadata tier is the thing that implements like directories, file metadata, all of the things that you think of as like when you go in like ls inside your Unix terminal.
Mhm.
That's like what I think of as like the metadata tier. Graph doesn't provide that. But what Graph provides is it provides like a file backend. So
Got it.
if you create a file and then you back it with Graph, the Graph will provide the like it will store the bytes of that file, and it will
Mhm.
add all these superpowers. Like you'll be able to like replicate the bytes of those files somewhere else, and that somewhere else will be able to only pull the bytes that it needs of that file. It won't have to read the entire file.
Man, I thought SQL Sync was like wizard stuff. I feel like this is next level. This is wild. Because
Yeah, if it works.
at that yeah, I guess at that point the whole like you're opening yourself up to physical corruption, right? Because you're just like you're slinging bytes around, aren't you?
Well, so Graft has a property which is that it's single writer. So Graft does not implement any kind of multiplayer layer. It
Okay.
literally is just like I have a writer at point A, and then I have infinite number of readers, and I
Got
want
it.
all of those readers to see the same version of this file
Got
all the
it.
time,
Okay.
and I want them to be able to update themselves like to the latest version of the file very efficiently, and I want them to be able to stream the version like the file as it changes, and I want them to only have to pull the portions of the file that they care about. But it doesn't implement any kind of multiplayer layer. So
Got
it
it.
will implement the like
Okay.
coordinator to client synchronization aspect of SQL Sync.
Got it. Okay. That makes a lot of sense and is very, very cool. So at that point, if I'm following correctly, at that point you've got um, graphed at least on the coordinator, um, and the whole rest of the system basically stays the same more or less, and you're sending streams of events. And the difference is when in the coordinator those are written to the underlying .SQLite file. Graft is in there. It's got its hooks in that file, and it knows the bytes that were changed, and it just it just sends those bytes out in a more efficient way than is currently happening with SQL Sync.
Yep, exactly.
Cool. So cool. Man, that is wild.
Yeah, so that's what I've been working on for the last almost 6 months, I guess. And I'm getting hopefully close to the point where I can actually have something released with that. But this project, like SQL Sync, was about 3 months of like full-time work, and this
Uh-huh.
project is probably about twice as big as SQL Sync. So I'm hoping to finish it
Yeah.
up in like the next month or two.
Wow. Cool. Um, and so one thing we didn't touch on, but it sounds like SQL Sync might be great for desktop apps. Is that right?
Yeah, it's another area that I want to really explore, like desktop and mobile apps.
Yeah.
Like I sort of originally designed it really focus on like the browser, but there's nothing really
Sure.
inherently specific about it. The nice thing about SQL Sync being pure SQLite is it sort of works wherever SQLite works.
Right. Yeah.
Um, One thing I am starting to experiment with though, which will make it even better, is like in SQL Sync, there's two layers of SQL Sync. There's the SQL Sync wrapper, which implements like the WebAssembly logic and like the multiplayer like rebase logic and stuff. That's outside of
Mm-hmm.
SQLite. And then
Mm-hmm.
there's like the part that's inside SQLite, which is like the VFS layer, the physical layer,
Sure.
stuff like this. With Graft, one of the things I'm experimenting with is building it as a completely native SQLite extension.
Hmm.
So my current like Graft test system that I use actually just uses like I use brew install SQLite and
Mm-hmm.
then I like install Graft into that SQLite and I can run
Just
Graft.
like dot load
Yep.
graft.
Yeah.
God, that
So I'm
rules.
going to the point where like you'll actually be able to drop Graft into like iOS native SQLite and just add it as an extension, or you could drop it into like wherever Bun SQLite, like whatever implements native SQLite, you should be able to
Mm-hmm.
drop Graft in, and suddenly you get basically like Graft will implement just the physical tier of SQL Sync, so it will give you like one way
Hmm.
super high performance replication, and then SQL Sync will be implemented as like another sort of layer that will be very, very lightweight, so you can add it directly on top of SQLite without having to edit SQLite. So I'm trying to
Mm-hmm.
build this in sort of like a more modular way, so it'll be easier to
Mm-hmm.
port SQL Sync to more places.
Wow. Dude, this is awesome. I knew that like SQL Sync was cool and I played with it in the browser and I was like, "Oh, this is really cool." This is blowing my mind. This is very, very cool.
Oh, I'm glad you enjoy it, and thanks for getting me to like open up and talk about it because
Yeah,
I
of
really it's
course.
been bottled up in me, so it's fun to chat about.
Yeah, I had the easy job here. Okay, so two things. What is next for SQL Sync and Graft? I know that what's next for SQL Sync is Graft, but like, where's Carl in a year or 2 years? Is this um, does this become a hosted offering? Does this just bolster your credibility? Like, what's the goal for Carl here?
So my immediate goal is make something that's useful. Like I don't really
Okay.
care about the next steps as much as I care about making something that's actually useful and not just like a toy. SQL
Mm-hmm.
Sync as of right now is more of a toy than something that like I would be comfortable someone building like a product on top of.
Okay.
So my goal right now is to make something that's like I could really stand behind and say I would use this to build a real product. And
Cool.
ideally, actually, I'd like to build a product on top of it, like make something real that people can play with and use. That's
Sure.
more than just a toy demo. So that's sort
Mm-hmm.
of the medium term goal. Um, well, short term goal is finish Graft. Medium term is
Yeah.
make something useful that is interesting, and then like we'll see where that goes. If it goes towards people are like, hey, this is really useful, and I want to build a product on it, then I think I want to start a company that's focused on that, like just completely making it as easy as possible for people to build interesting things on top of that technology. Um,
Cool.
if it's sort of like people are like, well, it's useful, but maybe there's other solutions or the market's too saturated, whatever, like, if it doesn't make sense, I think there's a lot of ways I can either pivot this or sort of go into like a slightly different direction. One of the reasons I'm building Graft the way I'm building Graft is because I don't want to pin myself completely into like multiplayer SQLite. I want to be a
Mm,
little bit broader. And so
that's
because
smart.
Graft is just a storage engine, you can use it to do a whole bunch of cool stuff. Like if you're just replicating, cool like model training data, for example, like you
Mm-hmm.
can use it to do that. So I'm
Sweet.
trying out a little bit more of an experimental like breadth first approach, and
Yeah.
then hopefully get some feedback later this year once I launch some stuff open source.
This this aligns with one of my deeply held beliefs that progress creates progress and motion creates motion. And like you started with SQL Sync and it's like very good, and then you realize, hey, there's this other thing that is needed, and it's potentially a lot broader and a lot bigger, but you never would have gotten there
Yeah.
without following your curiosity in the first place.
Exactly. And I've
Yeah.
always, yeah, I mean, I really like you've been a proponent of like just, you have to build your own luck. Like you have to
Mm-hmm.
do that. And I believe in that like really strongly. Like I think by pursuing what I find most exciting, most interesting and taking it very seriously, getting really nerdy about it, A, I'm like learning, B, I'm getting myself in a position where I can help others. And then C, I'm hopefully building something that I would want to use myself. And if I want to use it,
Mm-hmm.
then maybe someone else would want to use it. Is sort of my thought.
God, I love that. I'm so happy for you. This sounds like it's a lot of fun, and this sounds like purely within your zone of genius, and I'm just so freaking pumped for you.
Very kind of you, Aaron. Thank you.
Yeah. Well, thank you for telling me all of this. Tell people where they can keep up with you, where they can keep up with SQL Sync, and where they can hopefully soon, in the next few months, learn more about Graft.
Yeah, I mean, so SQLSync.dev is like the main host URL for SQLSync. There you're going to find like a blog post that I wrote that goes pretty much into detail about a lot of the rationale behind SQLSync, how it works. You'll also be able to find the to-do list demo, which I encourage you to play with, try to break it, see what happens. And then you'll also find a link to my the like SQLSync Discord server. That's
Cool.
probably the best place to go. Like if you're interested in any of the stuff I talked to, you want to chat with me, go on the Discord server, ping me. I'm always happy to answer questions. Always happy to find more people who like nerding about these topics,
Mm-hmm.
and I'm happy to chat about it.
Awesome. Well, thank you again for your time, and it's just always so fun to talk to you. So thanks for doing
Same
this.
with you, Aaron. It's nice to see you.
Yeah, you too. All right, we'll talk soon.
Yeah, talk to you later. Bye.